So in a previous video, we looked at the derivation of the linear, power, and exponential functions. So now we're going to look at how these work in MATLAB, and in particular, how the polyfit function works. Okay, so if you remember from a previous video, we have our linear function just follows the format of y equals mx plus b, okay, when we put it in linear form. For a power function, we know we can derive it and change it to be log y is equal to m times log of x plus the log of b. This is the linearized form of the power. And for an exponential function, we have the natural log of y is equal to mx plus the natural log of b. Okay, so the form of these equations is very important. So as we put them into MATLAB and use the polyfit function, it changes how we use the function. So in general, the polyfit function follows this format. So we have the constants, okay, which are going to end up being the m and b values and the b values. So there'll be 2 from this equation. And then we have the command polyfit. And we've put in our x, so whatever's on our x-axis, and whatever's on our y-axis. Okay, and what order function it is. In this case, these are all first order because the power on x is all first order. There's just one. Okay, and so this is a general form for a linear function. Okay, so if we were going to put this into MATLAB, we would just have our constants, okay, which I'm just going to use as a variable con. Okay, but this is a vector with 2 variables, which is our m and b values. Okay, equals polyfit x, y, and first order. Okay, so if we want to extract those values from this vector, we have m is the first position in the vector, and our b value is the second position in that vector. Okay, so this is for a linear function. Okay, so looking at adapting this to the power and exponential function, we just have to change what goes into our x and what goes into our y. Okay, so in this case, for power, our x is going to be log x, okay, and our y is going to be log y. For exponential, the x is going to stay x, but the y will be natural log of y. Okay, and you'll notice the log b and natural log b, we have to do a little manipulation with this term in order to get the value that we want for just b. So again, this is for our linear function here. So let's look at creating our second one. I'll just call this con p for our power function. Okay, and that's going to be the same function, polyfit. But in this case, instead of x, again, we're going to look at log. And now MATLAB is tricky. You have to use the word log 10 to indicate log base 10. Okay, log 10x, okay, whatever that variable is. And then we have log 10y. Okay, and then first order. Okay, and now probably need parentheses around these as well. Okay, so log 10 of our variable an x and log 10 of variable y and first order. And to solve for our m value, m we see is the same. So m will be the first position in this vector of 2. And b, because it is the log of b, will have to be, if we want to get rid of that log, 10 to that power. And that's going to end up giving us our values for the power function. And again, this is our power function general equation. Y equals bx to the m. Okay, so these are now the values for this equation. Okay, and we can plug in our value of x and get our best fit line y. So now looking at the exponential function, so this is going to be, we'll just put the constants of the exponential. So again, we're going to use polyfit. And we want to look at the x values, which will be the same in this case, no log there. But the y values, we have the natural log. And in MATLAB, that is log, for some bizarre reason, of the y. And again, first order, because we have only a power of 1 here for this value. Okay, and again, now we have the first value in this case is going to be our value of m. Okay, and our b value, you see, is the natural log of b. So we're going to have to do e to that power, okay, to cancel that out. Okay, and with MATLAB, this is exp. Okay, and our value for that second position in the vector. Okay, and so that's how you're looking at solving for the exponential function constants. Which again, here's our base equation for exponential. Y equals b e to the mx. Okay, so if we have our data set and we plot it, okay, and we're looking for what those constant values are for our best fit line, we use polyfit, enter our data in this way, and we end up with our constants for m and b here in our equation. We put those in for our data set x, and we end up getting our best fit line for y.